So my name is Bob Kinney. I'm a senior engineer working on API Gateway. And tonight we're going to be talking a little bit about how to operate your serverless API at scale. So just kind of a brief overview of what we're going to be talking about tonight. We'll do a real brief overview. Hopefully this will just be a review for everybody about what we actually what we're talking about when we talk about serverless with AWS, specifically focusing on API Gateway and Lambda. Then we'll talk a little bit about how you can customize your API using custom timeouts and gateway responses. Then we'll move into monitoring your API with CloudWatch logs, metrics, and alarms. Finally, next we'll talk about protecting your API with authorization, throttling, and usage plans. And then finally, I'll do a demonstration and show off our newly launched feature for updating your APIs with Canary release deployments. So what do we actually mean when we talk about serverless? Obviously, it means that there's no servers. Obviously, that's a little bit of a misnomer, but from your perspective, there are no servers for you to run. No more EC2 instances, no more dedicated hosts. It scales up as needed, so when you need the scale, you can get it. You never pay for the idle usage, you only pay for the invocations and the Lambda compute time that you're actually using. And as with all other AWS services, availability and fault tolerance is built in. So the first component, sort of the entry point, I like to think it as the entry point for the serverless model, is Amazon API Gateway, which is the service I happen to work on. So it allows you to create a unified REST API interface integrated with any number of services on the back end. It has built-in DDoS protection and throttling to protect your back end. You can authenticate and authorize your requests, as well as throttle, meter, and monetize your API usage to bill for third parties. So what you see on the screen is a high-level architectural design for API Gateway as it launched way back when, 2 years ago. So we have our clients, whether they be mobile apps, websites, or services, making calls over the internet through to a DNS name pointing to a REST API, which is fronted by a built-in CloudFront distribution, which then connects to the API Gateway service. Once it hits the API Gateway service, we have integrations with CloudWatch and a built-in caching layer before it eventually goes off to your integrations. And those integrations could be AWS Lambda, an endpoint running in EC2, any other AWS service, as well as any other public HTTP endpoint. So about a month ago, we launched what we call regional API endpoints. So many of our customers that were running services talking to API Gateway APIs were seeing higher than expected latencies. And part of that was due to the fact that the traffic had to go out to the CloudFront POP, then come back into the region to talk to the API Gateway service. So for those customers, we now offer this as a solution where you can actually talk directly to the API Gateway service and remove the CloudFront from the loop. This also allows you to put your own CloudFront distribution in front of your API and take advantage of edge caching if you want to. So the other half of the equation that we'll be talking about a little bit today is the AWS Lambda service. And hopefully everybody is familiar with this. It allows you to bring your own code, various runtimes from Node.js, Java, Python, and C#. You can bring your own libraries, a simple scalable, simple resource model where you actually just define the amount of memory that you want to allocate to your function. That also has benefits for the amount of CPU that you get. It's flexible use, so you can invoke it synchronously, whether for API Gateway or asynchronously via other events. And those event sources can be things like S3 or SNS or many other AWS services. And you can grant access to those selectively to those functions for access into your VPCs, as well as fine-grained control over your functions for invocation. So now we've set the table, I want to introduce you to my friend Doug. And Doug is a good Seattleite. He likes coffee. He also happens to work in the tech industry and writes apps in his spare time. So he's decided to link these two things together and build a service that he calls TAMPR. It's a service that allows customers to review coffee shops and coffee roasters. Doug's decided to build the entire backend for TAMPR completely serverless using API Gateway and Lambda. So Doug built the first version of this service, TAMPR, by aggregating some data from external sources. And so this allowed him to quickly develop and prototype it. Unfortunately, some of these third-party services aren't as reliable as he would like. And so some of the requests will time out. And the default timeouts for API Gateway are 30 seconds. So requests will take 30 seconds to time out, and this was causing some problems in his initial beta testing. So Doug would like a way to be able to control how long each of his invocations take and fail fast and build retry into his clients. So that leads us into our first topic, which is custom timeouts for customizing your API. So Lambda already has the already had the capabilities for setting the actual the cap on your invocation for your function. You can set that on a per function basis. Now, as of last week, you can now also set a custom timeout in your API gateway invocations. On the screen, it says 1 second. It's actually the minimum is 50 milliseconds, up to the maximum of 29 seconds. And you can set this on any integration type, whether it be HTTP, Lambda, or another AWS service. And you can set this on a per method basis. So now that Doug has custom timeouts, he's able to fail fast, do retries in his clients, and have a much better experience inside of his application, and is able to move on. So now that Doug has got his API working, he's built a mobile application, both iOS and Android, but he wants to build a website experience as well. He's gotten most of the basic functionality working, and has cores working in the happy case. But unfortunately, there are a number of error messages that or a couple of error handling cases that are not working, and the browser is actually reporting cores errors. This is because the, excuse me, even though he's configured his API to return those responses, API Gateway is generating those error responses and intercepting the configuration. So he needs a way to be able to add that configuration to the error messages being generated by API Gateway. Thankfully, there is a way to do this now. And that's a feature that we launched recently called Gateway Responses. So Gateway Responses allows you to customize the error messages returned by API Gateway in various error scenarios. So the things that you can customize are obviously the HTTP response code. You can modify the body content if you want to change the error message, as well as add headers, which is the thing that we're most interested in here. You can specify your gateway responses on a per error basis, or set default handlers for 4XX and 5XX error codes. So now what I'm going to go ahead and do is do a short demonstration of how we can actually set that up. Okay, so I have, I've got my API Gateway console up. I have a very simple API here that I'm going to go ahead and visit the Gateway Responses tab. And so you see here, we've got our default 4XX and 5XX that I was mentioning earlier, as well as a bunch of other specific error messages. I basically just want to add course headers to all of my error messages, so I'm just going to override the default 4XX and 5XX. So the first thing I'm going to do is actually add my headers for cores. So I'm going to add my methods. Because I'm putting static strings, I have to enclose those in quotes. Now we'll add our access control headers. And then finally, we will add our origin. Now here, obviously, I'm using star, but if you wanted to lock that down to a specific domain, you could do that here. And then additionally, I'm going to go ahead and update the error message and add a little playful error message. So I'll go ahead and save my gateway response. Now that's That just saves it into the API Gateway service. I do need to still deploy that change, so I'll go back over to the Resources tab, deploy it now, and deploy it to my prod stage. Now, this method is actually, so obviously I'm getting a 200 response here with some actual value. If I want to test my 4xx response, all I really need to do is just use a path that is not mapped in my API, and I'll get back the default 403 error message. So we can see here that we actually have our custom error message, and if I take this over to a command line and use curl, we can see that we're also getting our CORS headers. So this is an easy way for you to customize the error responses for all of the error cases that API Gateway may generate. So let's check back in with Doug. Now that he's been able to get CORS working and all of his error handling, he's able to build a JavaScript web app and complete the whole ecosystem that he's trying to build with TAMPR, and he's ready to go live. So we'll fast forward a little bit to the first reviews of TAMPR, and you can see here the early responses have been somewhat mixed, and that's probably putting it kindly. So obviously, Doug's having a little bit of problems with customers receiving errors in his API. So he needs a way to be able to figure out what's going on. And that will segue into our next topic. We'll be talking about monitoring, specifically using CloudWatch metrics. So both API Gateway and Lambda support a number of default metrics. The ones you see listed up here on the screen are the ones that you get by default for API Gateway. So that includes our count, which is our overall invocation count. That'll include both errors, throttles, any request that's received by the API Gateway service. Then we have our 4xx and 5xx error counts. These can also be graphed in CloudWatch with averages to get your percentage of errors, not just your overall error counts. We additionally emit two different latency metrics. One, which is what we just call latency, which is the time from when the API Gateway service receives the request to when a response is sent to the client. And the second one is the integration latency, and that's the time from when API Gateway sends a request to your integration from when it receives a response. So if you're interested in seeing the overhead added by using API Gateway, you take your latency minus the integration latency, and that's the overhead introduced by API Gateway. Additionally, if you use the built-in caching service, the built-in caching in API Gateway, we emit cache metrics for hits and misses. And again, these also can be used, these also can be graphed as averages to get your cache hit and miss percentages. So in addition to the default metrics, you also are able to add additional detailed metrics. These are the same set of metrics that we saw on the previous slide, but they are set on a per method basis. So it allows you to see more granular detail. You can set this at, by default in the stage level or override this on specific methods that you're interested in monitoring. So the default metrics are included free of charge, and they're broken down by the API stage. If you want to enable detailed metrics, standard CloudWatch pricing applies, so you pay on a per metric basis, and you can enable that, and it's broken down by method. Once we have metrics, then we are able to set alarms on those metrics. Any metric obviously can be tied to an alarm. The alarm notification can then be sent to an SNS topic, and that SNS topic can then have any number of destinations, whether it be an email address, an SQS queue, or if you wanted to double down on your serverless infrastructure, you could even invoke a Lambda function to attempt an automated mitigation. So what I'll go ahead and do now is demonstrate how we can set up some alarms based on some CloudWatch metrics. So I still have my existing API here, which is a very simple API. And I'm going to use a tool called Gatling to actually generate some amount of traffic to this API. All it's going to do is hit this particular method in my API, which is calling a Lambda function, which occasionally generates a 500 error message. So I'm going to go ahead and start up the Gatling script. I'm going to filter out some of the verbose logging that it generates. I'm going to go ahead and start my random errors test. And so what we're seeing here is apparently I did not fix my permissions. So I'm getting all 500s. That's great. So if I go over to the CloudWatch dashboard, what I should be able to see here, if I go over to the metrics and go to API Gateway stage, event 2017. And then look at my 5xx error count. What I'll probably see here is that if I graph the average, it's interesting. So what I should be seeing here is eventually a, there we go. So there's the last data point. Now I'm getting 100% of those errors are actually are causing 500s. So what I would normally do here is go ahead and set an alarm by clicking on this bell icon. If I choose 1 minute metrics. And so all I have to do is give it a name. And I'll set that for, doesn't really matter because the values we're doing 100% of errors. So we'll just say that if we were alarm on 5% error metrics for one data point. And then we'll go ahead and set my email address. So I've set up a temporary Gmail address for getting the alerts. And then I'll go ahead and create the alarm. So when I initially create the alarm will be in an insufficient data state. Eventually, what we should see is after about a minute, the alarm will have enough data to actually trigger the alarm and generate an email message to that Gmail address. And we've already seen it transfer into an alarm state. And if I go over to my email, hopefully we get our email. Not quite yet. So normally here at this point then, you would be able to have your operator respond to your alarm, figure out what the root cause of the problem is, and move on. So, of course, this is the part that decides to fail. So that says it's in an alarm state, and we still haven't gotten our email, unfortunately. Okay. Well, unfortunately, I just have to move on. Okay. Okay, so now we've got our alarms configured, and hopefully in production we're actually getting our emails quickly. So we know when we're having problems with our API, but we don't necessarily know why we're actually getting errors. So that segues into our next topic, which is specifically talking about logging using Amazon CloudWatch logs. So both API Gateway and Lambda have native integration with CloudWatch logs. So API Gateway offers 2 flavors of logging now. So the basic, more basic logging that was launched with the service offers basic request response logging, any transformations that you may have applied in your API, as well as overall request response status. Additionally, as of last week, we launched what we call access logging. And this allows you to customize a log line to receive inside of your CloudWatch logs that is akin to a Apache-style log format. So the common log format is one of the sort of the out-of-the-box formats that we can use to enable CloudWatch logs. On the Lambda side, we actually can log, the native logging is under your control out of your code. So anything that you log directly from your function ends up in your CloudWatch logs, and you can analyze it however you see fit. Once you have those logs, you can set up what's called log pivots. And log pivots allow you to set up filters to graph metrics. And so you can do search queries for specific error strings or search strings for status codes. And then once you have those metrics, you can set an alarm on that and then jump directly to the actual log entries that are generating the alarm state. So now we'll go ahead and actually see if we can try to diagnose exactly what's going on with our API. And of course, when we come back, we have our error. So the email did finally work. All right, so first things first, we'll go over to API Gateway. And all of the logging for API Gateway is set on the stage level. And much like the detailed metrics, can be overridden on a per method basis if we want. So I'm going to go to my stages, go to my particular prod stage, and then I'm going to enable logs at the error level, as well as enable access logging. Now, for unlike the default logs, for access logging, we can actually provide a log group to actually log all of our access logs to. This allows you to actually aggregate your access logs across multiple APIs, should you so choose. Or you can just create a access log group or a log group per API. The console has some default formats, so I'm going to go ahead and just going to use the CLF or the common log format. And I'm going to go ahead and save those changes. Then I'm going to go to my API and actually hit a endpoint that I know will generate an error. So if I just hit refresh a couple of times, you can see here that I'm getting an internal server error, default 500 5xx error. And if I go back over to the CloudWatch console and go to my logs, I should be able to find the specific request IDs as well as the status code in our access logs. So here's my access logs group. Hopefully we'll see some logs. Don't do this to me. Okay, so let's check and see if our regular logs have some data. You guys don't have it either. Let's double check and make sure that we've configured this correctly. Save my changes. Hit the API. Oh boy. Oh, here we go. Okay. So let me just go back to my access logs real quick. There we go. Filter by the time, and we get the data that we want. So I mentioned, so we can get a single log line, and then the Apache common log format. So we get our source IP, our request time, the path that was requested, our status code, the size, as well as a request ID. So this is really useful when you're requesting support, for instance. But it also allows us to search for our actual logs, the more detailed logs inside of our non-access logs for API Gateway. So if I flip back to my other log group and I search the logs, the request ID contains a separator character, so this needs to be escaped with quotes. I get my error message that was recorded by API Gateway that was generating the 500. So I see here that my permissions on the Lambda function are not correct. So I happen to have a quick line here to set those permissions correctly, which I'll go ahead and run from my CLI. And then I'll go back to my here, and now I've got my refresh. I've got a 200 response with the correct data. If I go back over to my logs, to my access logs, we can now see a 200 response with the same data with the request IDs. So this is a great way for you to actually look at the error messages being generated and then, or look at the errors being generated and then dig down deep with the request IDs. You could then take this request ID, pipe it into your Lambda logs, search your Lambda logs for those request IDs to look inside of your Lambda function as well. Additionally, you can use the access logs and export them to S3, send them to another, and send them to an analytics system if you wanted to get additional contextual information about the requests coming in on your API. Okay, so thanks to logging, Doug's been able to figure out that there was a bug in the original beta version of his application that was hitting a legacy API at a much higher rate than was expected. And that's using up valuable resources that his production customers the calls for his production customers aren't able to use. So Doug needs a way to be able to limit the impact of this bad version for this legacy API so that the resources can be used to serve his prod traffic. So that segues into our next topic, which is protecting your API with throttling. So API Gateway supports or has 3 levels of throttling. The first and the most granular is the API key level throttling. That's managed via usage plans, which I'll talk a little bit about later. But that's the most fine-grained ways that you can configure throttling. The next level is method level throttling. So that's configurable in the stage settings. You can set a default method level throttling in the stage, or as with other things, specify overrides on a per method basis. Then finally, an account level throttling is applied. And those limits are defined on a per region, per account basis. And you can request an increase in that as you need. Some important things to note, any request that is throttled is not billed. So if you need to protect your API from malicious attacks, this is one way you can protect your API from malicious attacks. So it's important to talk a little bit about how API Gateway actually implements throttling. Like a lot of AWS services, it uses a token bucket algorithm. That basically means that when a request comes in, a token is tried to retrieve from the bucket. If there are tokens available in the bucket, it takes a token. If there's no tokens available, that request is considered throttled. When we talk about token bucket algorithm, there's 2 values. The burst, which is the size of the bucket, how many tokens can actually fit in the bucket at any given time. And then the rate is how quickly tokens are added to the bucket, the replenish rate. When we normally talk about rates, we talk about rates at a RPS rate, so the number of tokens per second. But that's not to say that on a second boundary, tokens are added to the bucket. It's a continuous fill rate. So think of it more like a spigot rather than a bucket pouring into our token bucket. So now I'm going to go ahead and do a demo that will hopefully go better for enabling throttling. So I've got another Gatling simulation that hits a specific method in my API, and then I'm going to go ahead and start that up, and then we'll enable throttling on it after the fact. So I'll go ahead and start up Gatling again. I'll start my throttle test. Hopefully this one's not generating 500s. Okay, these ones are okay, good. So what we're seeing here is that all of these requests are generating OKs or 200 status codes. That's because I've not enabled any throttling on this API at all. We're roughly doing about 100 RPS. And what I'm going to go ahead and do is throttle that down to a much, much lower rate. So as I mentioned, that's going to be set in the stage settings. And I'll go ahead and enable throttling. And I'll go ahead and set it on the specific method. So go down to our get method and set overrides on the stage, enable throttling, and then I'll set a much lower limit here. So I'll set 2 RPS. Now, hopefully what I'll see is pretty much instantaneously, or is about as instantaneous as it can be. Yeah, there we go, great. So we're starting to see some KOs. So that means that we're getting some 429 responses in response to some of these requests. Now, some requests are still getting through and getting OKs, but the rest of them getting 429s and not showing up on my bill. So obviously, I was setting small values here. You can actually set fractional limits. Basically, about the absolute lower limit on the throttling rates is about 1 RPM. Anything lower than that, and we would lose some of the granularity. But okay. So checking back in with Doug, now that he's been able to throttle the bad API, his production customers their traffic is getting through. They're no longer getting errors. The reviews are starting to improve, and the customers that are using the old buggy version are going to get some 429, sure, but those are beta customers that he can do some soft touch and get them to upgrade to the new production version of the app. So because because the experience has improved for his production customers, some of the coffee shops and coffee roasters have started to notice that their customers are using this TAMPR app. And they've reached out to Doug to actually talk to him about adding promotions inside of the application so that they can offer some coupons for valued repeat customers. So Doug needs a way to open up a portion of his API so that these coffee shops can actually submit the promotions without him having to be a go-between. So that'll segue into our next topic, which is talking about authentication and authorization in API Gateway. So what you see up on the screen is a various comparison of a number of the authentication types or authorization types that are supported in API Gateway. Excuse me. So all the way on the left, we have AWS IAM. So that's using actual AWS credentials and doing signature version 4. Then a policy is applied to those credentials, and we can validate that policy against the ARNs describing the API. Next up is our token authorizer, what we used to call the custom authorizer. And the custom authorizer allows you to write your own Lambda code for validating what we call the token source. So that would be a specific header that would actually contain, in most cases, like an OAuth token or an OIDC token that you can crack, validate, and return a yes or no response to say whether or not this token is valid. To sort of emulate the same functionality that you can get with IAM, you return a policy associated with that token. And that policy can be cached for up to 60 minutes. And that policy is expected to describe all of the permissions in that API that the customer, that token, can actually use. Very recently, we launched what we call the request authorizer, which is an evolution on our token authorizer. So instead of just having a single header, you can actually have multiple headers or query strings passed to your Lambda function to do more complex authorization strategies. And then finally, we have support for the Cognito user pools for authorization, or at least authentication. So if this is good if you want to be able to offer access to only logged in users, but you can't use this for, at least not today, for controlling portions of the API that a customer has access to. So the thing to highlight here is, or a couple things to highlight here. So for both AWS IAM and Cognito, there's no additional charge for adding this kind of authorization. And for the token authorizer and the request authorizer, you pay for the invocations on your Lambda function. But if the request is denied by policy, again, API Gateway does not bill for a failed authorization request. OK, so now I'm going to go ahead and do a demo of a custom authorizer. So this is actually a request that we've seen in the past for customers with legacy APIs. So I'm actually going to implement basic HTTP auth for my API Gateway API. So I've actually already set up my authorizer. I've set it up as a request authorizer. Strictly speaking, basic auth doesn't actually require multiple headers. It only requires the single authorization header, but I've configured it as a request authorizer here to use the new feature. So I'm using the authorization header, and I can go over and actually look at that code in the Lambda console. And so my request authorizer is just then going to take the, it's all the way down. So that it's just going to take the authorization header that gets passed in, base64 decode it, figure out what the username and password is, and then compare it against a hard-coded set of credentials. Obviously, you could use this to link up with a database with a username and password store, should you so choose. And then any user that's not authorized, we will return an unauthorized request and basically just reject the authorization. So now I'm going to go back to the API Gateway console because there's one other piece that I need to configure, which is the response when no authentication is presented, so a 401 error. So in basic auth, I need to make sure that I actually return an appropriate header to tell the browser to prompt the user for the username and password. So we'll go ahead to the gateway responses. I'm also going to go ahead and reset this guy just so that I don't get this later. And it's already here, leftover from a previous demo. So I've added the www authenticate header with basic. So when I hit my API without credentials configured, I should get a prompt. I'm going to go ahead and copy this and start an incognito. And so as you can see, I get my 401 response back, and my browser is now prompting me for a password. So I'll go ahead and enter in my unprivileged user. And I get a response telling me about my user information. So this is actually using the contextual information you can pass back from the custom authorizer. So any key value dictionary or any key value you want to pass back from your authorizer, you can do so and then ingest it inside of your actual business logic functions. So this user is only allowed to access this specific method. If I try to access a more privileged method, I should get an error message. I didn't deploy that change. Of course I didn't. So I get my default error message, which is left over from my 4xx error message tests, indicating that I don't have access to this method. If I go ahead and terminate this incognito session and open up a new one, and then log in with my privileged user, actually type the password correctly. It's now telling me that I'm logged in as the admin user. So the authorizer has sent back the contextual information that I'm logged in as the admin user. And then if I go and try to access my privileged resource, that also, I get a valid response from here as well. So this way, I'm able to actually protect portions of my API using HTTP auth. OK, so checking back in with Doug again. The promotions have been a hit, and so TAMPR is growing even larger than it was before. And now he's actually talking with other services that are interested in partnering with him, like a new service that's actually that reviews brunch spots. And they're interested in cooperating together and sharing information. So now Doug needs a way to be able to share aspects or portions of his API with these third parties while also tracking usage and limiting usage for potential billing purposes later. So that'll be our last topic about protecting our APIs with usage plans. So usage plans are a way for describing a set of permissions or throttling for a given API key. So there are basically three parts of the usage plan. The throttling rate, which is using token bucket algorithm, so rate and burst, and that's and that is applied on a per key basis. So every key in the plan gets the throttling limit. Additionally, you can also set quotas. So that's for periodic usage for daily, weekly, or monthly limits. And then finally, we also get built-in daily usage reports on a per key basis inside of the plan for use for billing. Additionally, there's also native integration with usage plans in the AWS Marketplace. So if you're actually interested in reselling your API, you can set up a plan, list it inside of the AWS Marketplace, and then AWS will actually take care of the billing and metering for you. So that Doug is integrated with usage plans, TAMPR is growing even more. And now he's starting to run into some scaling problems based on some early design decisions that he made when he first wrote the app. He's gone ahead and rewritten those portions with the greater understanding of the API at scale. And even though he has unit tests and he's gone through and done some load tests and debugging, he's still a little concerned about flipping 100% of the traffic in sort of one big bang. So he needs a way to be able to slowly roll out this update to a portion of his traffic, validate it, and then increase it over time. And that's where I get to talk about the brand new feature that we just launched today, which is called Canary Release Deployments. So brand new, just available today. Canary Release Deployments allows you to tag a deployment as a canary for your stage. So normally, when we set up a stage, or when we create a deployment, we associate it with a stage, and 100% of that deployment receives traffic. With the Canary deployment, you can specify the percentage that the Canary receives based on, compared to your regular deployment. You get isolated metrics and logging, so you can see just the logs metrics for your Canary, and any changes that can be tied to a deployment can be tested with the Canary deployment. This includes things like stage variables. So now I'll go ahead and demonstrate using Canary deployments. Okay. So inside of the console, the first thing I need to do is actually enable the Canary deployments. So over on this new tab, I have this new button for creating a Canary. And when I first create the Canary, API Gateway sets up the same deployment that's already set as prod as my Canary. Now, when I try to go to deploy, first thing I'll do is actually set my values for what I want my Canary to receive. So I'll go ahead and say that I'm going to send 10% of the traffic to my Canary. Go ahead and click OK. And that's immediately applied at the stage level. Then, if I go back to my API definition and do a deployment, you'll now notice that my prod stage, the console is noting that my prod stage is Canary enabled. So the console, by default, will force you into deploying to your Canary first, then you promote your Canary up to the production stage after you've validated it. The API allows you to bypass this if you want, but this is the recommended workflow that we want to encourage customers to use. So deploy to your Canary first, test and validate, dial up the traffic, eventually promote the Canary to your production stage. So once I deploy my Canary, I'm going to go ahead and actually start up my my Gatling requests again so that I can see some metrics. So I mentioned that we also get isolated metrics and logging. Now, even though I'm able to see the metrics and logs in isolation, they also get rolled up into your regular metrics. So it's not just, so you don't have to worry about looking at both at the same time. You can look at your specific Canary metrics, but you can also look at your service in aggregate. So I'm going to go ahead and start up my throttle simulation again, just so that I can get some traffic on my API. And then if I go over to the CloudWatch console and go to the metrics, API gateway by stage, go to my reInvent 2013 API, you'll notice here that I have both a prod stage as well as this prod/canary stage. So the prod/canary is the specific Canary metrics. So if I graph both the count for the overall API as well as the Canary, and graph the sum for 1 minute, what we should eventually start seeing is on these last data points, once we start actually getting requests. What we should eventually see is that we'll get the overall count of the number of requests that are coming into the API, and then we should see roughly about 10% of the requests going, 10% of that number in any given minute period going to the Canary. Okay, so our last data point, we got so about 88,000, or roughly about 89,000, going to the whole stage, and then roughly 10% of that, 8.9 thousand, going to the Canary. So this allows you to, so all of the same metrics that we talked about before, your 5xx, 4xx counts, latencies, are available inside of the Canary stage. So you can set your alarms and actually do automatic rollback with Lambda should you breach any sort of your SLAs on your API when you do your Canary deployments. You can also, if you want to, automate the promotion. So you can set up a CloudWatch event that would trigger the promotion of your Canary to your production traffic, assuming that you haven't breached your thresholds. So additionally, we also have our access logs and our regular logging, also with the /canary convention. So our access logs /canary, our stage logs /canary, and we can see the individual requests going to our Canary stage to then eventually look back. So as we can see here, these are obviously the 429s because I still have the throttling enabled on this method. And that's Canary release deployments. Okay, so TAMPR is growing so much that now Doug is actually doing this as his day job, and he's actually brought in additional people to work on TAMPR. So he needs some process and some process in place to help bring these people on board and maintain the overall operations of his service. So now I'm going to talk a little bit about some of the various methods you can manage your API lifecycle. The first and most basic is the API stage. So we already saw that when we were talking about Canary release deployment, but the API stage is a named version or a named deployment, and the intention is to use this for various versions of your API, whether you call that dev test prod or alpha beta gamma, different versions as you promote through. It supports parameterized values through stage variables. So if you have a different database per stage, you can set that as a stage variable to pass down to your integrations or your Lambda functions. The next thing for managing your APIs is custom domains. So this allows you to run your API inside of your own DNS. So by default, when you create your REST API, you get a Amazon AWS.com domain with a GUID representing your REST API ID. If you want to put a DNS name on top of that, you can configure that with a custom domain inside of API Gateway. This is actually one of our recommendations if you're interested in versioning your API, so that you can actually maintain your 2 versions as independent REST APIs and iterate on them independently. So you can set up API, for instance, API tampr.com/v1 to go to the v1 version of your REST API, and api.tampr.com/v2 to go to your v2 API. And with the launch of regional API endpoints, now there's no longer a restriction, so you can actually create the same custom domain in multiple regions, which allows you to do either failover or active-active multi-region redundancy. And there's actually a workshop focused solely on this topic. So if you don't have time to do that while you're at reInvent, the materials will be available later, so do check out that if you're interested. So now we also need a way to actually describe our APIs. Now, certainly you can go through and click through the console and configure your API that way. But it's really nice to be able to actually describe the API in a definition that you can view and treat as code. And the default supported mechanism inside of API Gateway is with Swagger. And if you're not familiar with Swagger, it's a standard from the Open API initiative. Currently, the 2.0 version is a subset of 2.0 version is supported inside of API Gateway, and I do realize that 3.0 is available, and we have plenty of customers asking for that, and we will definitely consider adding that in the future. So Swagger supports JSON and YAML as the actual definition, and you can import Swagger as well as get it back out. So this is a great way to actually replicate your API definitions across regions for that cross-region redundancy we were talking about earlier. Additionally, AWS has what we call the Serverless Application Model, or SAM for short. And we see here Sam the squirrel, which is our mascot for the Serverless Application Model. So SAM is an extension of CloudFormation. It simplifies some of the API Gateway-specific configuration in CloudFormation such that you write much less boilerplate in order to set up your API. So you have a bunch of resource types, including functions, APIs, and tables, so you can simplify your DynamoDB table provisioning as well. And because it's an extension of CloudFormation, you can actually mix and match and add additional CloudFormation values as well. So highlight there. So things like S3 or Kinesis or step functions, if you want to add those as explicit CloudFormation resources on top of your SAM template, you can do that. SAM also supports parameters and mappings and outputs, same as any other CloudFormation stack. And supports intrinsic functions as well as import value. And like the Swagger definition in CloudFormation itself, it supports YAML or JSON as the actual language for definition. So I would be remiss if I didn't also mention that there's a number of other methods for doing exactly the same thing. So things like AWS Chalice or Serverless are popular frameworks for actually describing and deploying your APIs. So feel free to use whatever tool you feel most comfortable with that actually helps you in your own process. So once we actually have our definition and we have our code, we need some way of actually deploying it, building and deploying it. And so I want to highlight a couple of other services. First is AWS Code Build. If you're not familiar, it's our managed build system. So it's a fully managed build environment. Much like other AWS services, you pay only for the compute time that you actually use. It scales up for your needs for your building, and it integrates natively with CodePipeline and Jenkins. It can also be used as a test step inside of CodePipeline, which is the next service that I would like to talk about, which is a mechanism for actually describing and visualizing your promotion through your various stages of your application's lifecycle. So this allows you to build continuous delivery pipelines for your APIs. You run your code build step on commits. You deploy it using CloudFormation or code deploy. You run tests, again, either with Jenkins or with code build, and then do promotions based on whether or not those tests pass or fail. So that brings us to the end of the talk. And if I can get you to take away anything from this talk, it's to be like my friend Doug. And you can be like Doug by customizing your API for your operational needs by adding headers or generating customizing your error messages. Monitor your APIs with CloudWatch logs and metrics, and set up operational alarms. Use the logging to actually diagnose and correct those errors. Make use of the throttling and authorization built into API Gateway to protect your API from bad actors. Make your API available to third parties listed on the AWS Marketplace if you so choose, as well as manage your API with the tools that make the most sense for your environment. So if you're interested in learning more, the serverless homepage, aws.amazon.com/serverless, is a great jumping off point to get to documentation and other services in the serverless family. And then there's some additional ways to connect out with us. First and most obvious is the AWS forums. So these are service-specific forums where you can ask questions from other users as well as the AWS service teams. Additionally, Stack Overflow is obviously a great resource for getting community support, but AWS engineers also do monitor these forums, specifically the tags that are tied to their service teams. So that's another way to get support as well. And then finally, the GitHub repositories. So GitHub/AWS, which is where most of our official SDKs are housed, and then the AWS Labs organization, which is where a lot of our demos and examples, as well as SAM live. So that's everything. Thank you very much for coming out. Do please fill out the evaluations for the talk. That's a great way to make sure that, for myself and for the company, to make sure that we're providing great content for you every year at reInvent, so that we can continue to improve. So thank you very much.